Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, getting your agent off your laptop and in front of real users. And one deployment mistake whose symptom is so weird, it sends people debugging in completely the wrong direction.
Before the targets, there's a design idea here I want you to set up. The same agent code is supposed to run everywhere.
That's the foundation, and it's deliberate. ADK separates the agent definition from the deployment. The exact same LLM agent code runs unchanged, whether it's on your laptop under ADK Web, or on Cloud Run, or on a managed Vertex service. Where you deploy is a configuration choice, not a code change. So this whole topic is about picking a runtime, not rewriting your agent.
Good. So what are the runtimes? Lay out the menu.
3 paths, and the cleanest way to hold them is as a ladder of effort and control. Bottom rung, Vertex AI Agent Engine. Lowest effort, lowest control. Middle, Cloud Run. Medium effort, your own container. Top, GK, Google's Kubernetes. Highest effort, total control. And the rule of thumb is simple. Start at Agent Engine. Climb only when you hit a real wall.
Take the bottom rung first. What is Agent Engine actually giving me?
It's Google's fully managed runtime for ADK agents. You run one deploy command, ADK deploy agent_engine with your project and region. And Google does everything else. It packages your agent and its dependencies, provisions a managed endpoint with autoscaling and session storage, and hands you back a stable resource name that is your endpoint. No Dockerfile, no Kubernetes, no serving framework to choose. Your service just calls query on it and gets the answer back.
That sounds almost too easy. What am I giving up?
Opinions. Google's. Agent Engine makes the calls for you, which Vertex region, managed session storage, Google's autoscaling behavior. If those fit your needs, you just save days of infrastructure work. If they don't, say you need a specific VPC, or a region Vertex doesn't offer, or a sidecar for an internal proxy, you'll outgrow it. And honestly, the industry take is that for most teams shipping their first production agent, Agent Engine is the right default. Don't over-engineer the deploy story before you even have traffic.
Okay, middle rung, when does Cloud Run earn the step up?
When you need your own container. Cloud Run is a serverless container runtime. You hand it a Docker image and Google scales it from 0. ADK even gives you a deploy shortcut that builds and pushes the container for you. The win is control over the box. Your Python version, your base image, your system dependencies, sidecars for connecting to internal services, plus the standard Cloud Run kit. Custom domains, IAM, a VPC connector for private resources.
Scaling from 0. That phrase usually has a cost hiding in it.
It does, and it's cold starts, because Cloud Run scales all the way to 0 when idle. The first request after a quiet spell pays a startup tax, and for agents that can be 2 to 5 seconds. That's genuinely meaningful if your traffic is spiky and users are waiting. You can pay to keep a minimum number of instances warm, which trades money for latency. Under the hood, by the way, ADK just scaffolds a normal FastAPI web service with a /run endpoint. And knowing it's plain FastAPI is exactly what saves you when you need to debug it.
And the top rung, GKE. Who is that actually for?
The honest answer, fewer teams than you'd think. GK is the heavy machinery. You operate the cluster, you decide everything, and ADK doesn't deeply integrate. You containerize the normal way and deploy as a standard Kubernetes deployment. It makes sense in 3 cases. 1. You already run GK clusters and want one platform for everything. 2. Your networking is genuinely restrictive, air-gapped, custom service mesh, mandatory sidecars. 3. The scale is huge. Tens of thousands of requests per second. GPU nodes for local inference. Otherwise, it's overkill. GK is the right call when you already have Kubernetes-shaped problems.
See now, You opened with a weird bug. I want it. What's the mistake whose symptom misleads everyone?
Here it is. And it's the most important thing in this lesson. On your laptop, you develop with an in-memory session service. State lives in one process. Totally fine for Dev. The trap is shipping that in-memory session service to Cloud Run or GK. Because in production, those scale by adding replicas, and any restart wipes the in-memory store. So conversation history silently vanishes. Every restart, every time a new replica picks up the request.
Oh, so to the user, it looks like the agent randomly forgets who they are mid-conversation.
Exactly that symptom. The agent keeps forgetting me. And that's the cruel part. It reads like a bug in your prompt, or your model, or your memory logic. So people go debug all the wrong things. But it's purely a deployment mistake. The fix is to always swap to a persistent session backend before production. Vertex's managed session service, or your own on Firestore or Memoristore. The session service is just a pluggable interface. Pick the one that matches your infra. And note Agent Engine sidesteps this entirely, because managed session storage is included. You don't even configure it.
So the symptom points at the model, but the real cause is where the state lives. That's a genuinely sneaky one.
It's the classic. And there's a broader lesson sitting right next to it. The deploy target is rarely your bottleneck. Token spend, model choice, and prompt design dominate agent quality, cost, and latency. Not whether you're on Agent Engine versus Cloud Run. So pick the simplest deploy that works, pour your real engineering effort into the agent itself, and only revisit the deploy decision when you have actual traffic and actual numbers in front of you.
So the one sentence to walk away with:
Start at Agent Engine and climb the ladder only when you hit a real wall. And whatever you do, never ship in-memory sessions to production, or your agent will look like it has amnesia.
crisp, that's the Datarekha audio guide. See you in the next one.